Hello students, welcome back to my channel Concept Tech 2018. I am Dr. Sunanda Manke and this video is a part of series on online electronics laboratory, and in this part we'll discuss the lab exercises on analog to digital and digital to analog converter circuits. This is the list of experiments which will be performed in this part. We have one experiment on analog to digital conversion using flash converter. Then two experiments are on digital to analog conversion, weighted binary method and R2R ladder network method. The last experiment is on binary code conversion and it will be performed in virtual lab. This is the experimental setup which will be used to perform a to D and D to A conversion experiments. This is the trainer kit, and outer one is the general purpose kit on which this trainer kit is mounted. The DC supply to this trainer kit is provided by these knobs given here. Then we have input switches here. Digital input is given through these switches, and you can observe here these switches are having two positions, high and low. So we can change the position of the switches and accordingly we can apply 0 or 1 input to the D2A converter circuit. So digital input is provided using these switches. Then we have this variable analog input knob. With the help of this knob, analog input can be varied and it can be connected using these 2 points here. And this is the voltmeter which is used to display the voltage, analog voltage here. So when we are converting analog signal to digital signal, the input is given by this knob and the output is observed on the LEDs which are available here, or even they are available in the kit as well. And when we are doing the experiment on digital to analog conversion, the digital input will be given through these switches and analog output is measured on this meter. Although this acts as both voltmeter and ammeter, but we are going to use it as a voltmeter. This is the trainer kit on which experiments will be performed. You can observe here we have a flash A to D converter, 3-bit converter here. Then we have this weighted binary D2A converter here and R2R D2A converter is here. So these three experiments will be performed using this trainer kit. The second assignment is weighted binary digital to analog converter. This is the circuit of weighted binary D2A converter where the 4-bit digital input is applied here and analog output is obtained at this point. The input is applied using switches as discussed in the previous slide. So we'll give either 0 or 1 through switches to these inputs, and the analog output is observed on the voltmeter that also we have seen in the previous slide. So for the change in the input sequence, we'll observe the analog output voltage. Let's do this experiment. Let's do the experiment of binary weighted D2A converter. You can observe the circuit here. It's a weighted binary D2A converter. These are the 4 digital inputs given through switches. Switch 1, switch 2, switch 3 and switch 4. High and low of switch can be done. Right now the position is low. This is the output which is connected to the voltmeter. So voltmeter will give us analog output for the given digital input. We'll change the position of this switch one by one and we'll observe the analog output for corresponding bit values. We'll start with 0, 0, 0, 0. All the switches are up, so value is 0. Now we'll make 0, 0, 0, 1. It gives 0.3 volts at the output. 0, 0, 1, 0. Switching one off and switching another on. It gives us a value of 0.6 volts. Then 0, 0, 1, 1. It gives 0.9, 0, 1, 0, 0. Switching off 2 switches, switching on the switch 3. So it gives us a value of 1.2. Then 1, 0, 1 gives us a value of 1.5. 1, 1, 0 gives us a value of 1.8. Now we have to make 3 switches high, 0, 1, 1. You can observe 3 high switches and 1 low switch. This gives us a value of 2.2 volts. You can see 3 switches are at high position and 1 switch is at low position, which is giving us 2.2 volts. Now we have to make 1 0 0 0. All the switches are to be closed, and then they are to be, and this gives us a value of 2.5. Then 1001 gives 2.8, 1010 3.1, 1011 3.4, now 1100 3.7, 1101 4 volts, 1110 4.4, 1111, all high switches gives us 4.7 volts. You can check for 4.7 all the switches are down, that is all the switches are at one position, high position, so it gives us 4.7 volts. Thus we have converted digital input to analog output. Let's check it again for all the values. We'll just observe the voltmeter reading 0.3, 0.6, 0.9, 1.2. At 0.9 it is 0011, right? Too low, too high. Now we'll make 0100, right? It is 1.2, 1.5, 1.8. Then we'll get 2.2, 2.5, 1000, 2.8, 1001, 3.1, 1010, 3.4, 1011, 3.7, then 4.0. After 3.7 we'll get 4.0, 4.4, and last reading is 4.7. We have observed in this experiment that when the digital 4-bit input is applied, the output value is proportional to the digital input given. As the input binary value increases from all zeros to all ones, the analog voltage increases from 0 volts to maximum value, that is 4.7 volts. And thus this circuit works as a 4-bit digital to analog converter circuit. I hope you have understood the working of the given circuit. Thank you.